So my name is Insua. I work for Nojitsu, where I work with the geniuses at Nojitsu. Today I'd like to talk to you, as soon as I get set up here, about building JavaScript-powered hardware with JavaScript. Is this confusing for anyone, this title? Yes? Okay. Man, I cannot get this thing to work for me. So I think the first thing that we need to do is talk kind of about how you build JavaScript-powered hardware, just to start, right, before we go into the inception of creating hardware that creates other hardware, all powered by JavaScript, of course. And I'd like to preface this with anybody can do this. I mean, start this up. Anyone can do this. If I can do it, you can do it. About a year ago, I knew nothing about this stuff, and now I think I'm okay. Not that great. So, the hello world in the hardware world is blinking an LED. And how many people know what an LED is? All right. How many people have used an LED? Okay, this is awesome, so I don't really have to explain it, but in case you don't know, there's an anode and a cathode, positive, minus. The long pin is positive, small pin, cathode. When you apply voltage, it emits light. It's pretty simple. And here we have an Arduino Uno, which is actually running an Atmel chip. So it's just a wrapper around an 18 mega 328p. There's a whole family of chips that you could use in place. Like you could build your own Arduino just using one of the Atmel chips, and it would actually run the Arduino software. So let's go like right down to the chip level. Can you see that? Kind of. Okay. If you were able to see the comments there, you could see that there's some crazy bit shifting going on here. Up here, we create a pin, or a binary representation of pin 13, so that we can turn it on and off. And then we loop, just forever, and we turn the port on and off. And I mean, if you understand bit shifting, which you don't really need to, hopefully, and if you do, then I'm sorry, then it's pretty easy. And then, okay, so Arduino is not only like the hardware, but it also provides libraries, like a standard library that wraps all of that bit shifting that I just showed you. So the lines of code, the count, kind of went down a little bit. So instead of bit shifting, you're actually calling like these functions that are setting up the ports and saying, oh, this can be an output or an input or all that stuff. And then they have this loop function, which is called like inside of the library somewhere. And you just turn the pin on, delay, turn it off, delay, etc. And so now, to prove that Hello World in JavaScript using Johnny 5 is worthwhile, I mean, this is a very small example. It's basically 3 lines of code, as opposed to having to work with bit shifting and like ORs and XORs and like all that nonsense. This just makes a lot more sense because we all know JavaScript and it's easy. It's easy for us. So before I got into hardware, I kind of mess around with music a little bit. Not very good, but I had this Chord Nano drum pad thing. And basically it's a MIDI drum pad, and it didn't work the way that I wanted it to, and eventually it broke. And so at that point I took it apart, and I realized like, oh, this thing is not really that complicated. It's just, I don't even know if it was pressure sensitive or velocity sensitive. And I'm like, oh, I can build a replacement. As opposed to buying, I can build just build it out of stuff that I find around the house. So I use some packing foam, some plywood, an Arduino Uno, some infrared LEDs. And this is like the 4th iteration of it. I don't know if you can really see that. But there's a link, the Empire.com project, Tempad, where it goes through I think it's 4 previous iterations. And so, knowing that I can build something just with stuff around the house, I kind of thought, oh, well, why can't I make something awesome by, actually putting some thought into it and, ordering, fancy wood and aluminum from the internet. So I had my little brother come up with a 3D model for what, I said, oh yeah, this is what it should look like, and it should be enclosed, it should have, silicone buttons, square holes, RGB backlit, so you can see what you're pressing. And so one of the problems with these design requirements is that cutting square holes and cutting molds for silicone, it's kind of difficult by hand. It's very error prone and tedious, and a lot of other stuff. So I ended up yak shaving for a month and a half and building a CNC machine. And so this thing allows me basically to make or move a cutting tool in 3 dimensions and remove material from work, as they say. So basically here I'm cutting plywood, and I'm cutting out square holes, just like I wanted to, so I can put silicone buttons through them. So a CNC machine is basically a computer-controlled cutting tool that works off of Cartesian coordinates, X, Y, and Z, and allows you to position the cutting tool within range. Within range, so that you can actually make precise cuts in the physical world, which is really awesome. And with the CNC machine, there's basically 2 parts to it. There's linear motion and linear actuation. Linear motion is basically the rail, like this guy, and it makes the car go in one direction. It's very precise. And you can kind of align it so that it's square with other axes. And the linear actuation portion of this is the actual stepper motor and driveline. So in this case, in this case I'm using a belt and a pulley. So here's an Arduino example of how you would actually step the stepper motor in a way, well, in a very minimal way. So I have a stepper driver and an Arduino Uno, which I've hooked up. And the driver is hooked up to power and then up to the stepper. And with this, we can use the Arduino serial monitor, and the code here is very simple. I mean, it's basically the same thing as the flash LED, except I'm using serial as well. So when I set it at 1, it's going to turn the direction pin high or low, or high. And when I set anything else, it's going to set it low, which means ground, or essentially ground. And then, no matter what I set, it's going to pulse pin 2, which is the step. So it's going to say, go this direction, and step. So if I just punch a bunch of zeros in here, it moves a little bit. And this is because, sorry about that. This is because the stepper motor, generally makes 200 steps per revolution, and so I got to send it a lot of zeros to make it actually do what I want. Ugh. You guys see that kind of? So it won't fall off. That would be unfortunate. Alright. So we go back the other way. Yeah, very exciting. So this is just kind of proof that linear motion, linear actuation, working together, and like you can actually write the code yourself, and it's very simple. I mean, it's 30 lines of code. The problem is you have to like go over the serial port every time you want to send one single step. So if you're stepping, 6,000 steps, that's 6,000 times across the serial port. So what you want to do is you want to actually put all the code on the Arduino, and then you just want to say, hey, go to this X, Y, or Z, right? As opposed to stepping it from across the serial port. And thankfully, there's this library called Gerbil that does this. Actually, it's not a library, it is a program that runs on the Arduino Uno, or the ATmega 328P. So you don't have to use the Arduino, but it is readily available. I mean, you could at your own board and include stepper drivers on it, and this has been done. So, I always wish that I could bring the CNC machine with me, but unfortunately it's just way too big, and I think eventually I will, and there will be a machine here like doing cuts and whatnot. But for now, I'll show you a virtual CNC. And so this is using 3JS to kind of show a CNC machine in action. And if I type in some G code, it will actually move the machine. And every time I stop typing, it will go again. So this is pretty cool, right? So now without a full CNC machine, I can actually show you how I build hardware using JavaScript. And so this G code, there are ways to generate this using CAD software and whatnot, but I like to have a little bit more control, and so I actually write code to generate the G code. And this stuff, this gets crazy really fast, because when you want to cut inside of a bound, you have to compensate for the width of the tool. Right, so when you're on the right side, you want to go minus, and when you're on the left side, you want to go plus. That way you're always inside by the bit radius, which is, it gets crazy when you start getting into this. But basically, my point here is it is possible, and we'll show you. So this G code is actually for a revision of a button mold for silicon. And if I run it, it just outputs tons of G code, right? So it's actually all of the steps to mill out from machinable wax, a bunch of pulls, so that you can pour silicon into it. So if I copy that guy and throw it into the simulator, it'll actually start and this particular example is kind of boring because it's just going to go down like 16 times, just like this, just layer after layer. And so this is the inverse of a 3D printer, which actually just add stuff. It's kind of an important distinction. Although a 3D printer like a MakerBot or a RepRap, they use the same sort of linear motion and linear actuation techniques. Okay. So using the CNC machine to cut out all this stuff for me, I was able to build this guy, which I call the temp pad, which is the current revision of the replacement for the drum pad. And I'm so far down the rabbit hole, it's not even funny. I mean, I've spent so much time, and now I'm just obsessed with just building more hardware, and it's just an exciting world. There's so much going on. There's so much that you can do, and then you can interact with JavaScript, or use JavaScript to interact with this hardware. I don't know, it's just fun. So these buttons are silicone poured by me, or milled from a wag, or basically I created the whole thing, and all the parts were, well, most of the parts were generated from the CNC. So I put in a sheet of aluminum, and then I cut out round holes for the silicone to come through. So I probably should show what this thing does. So without a serial connection, they're all pressure sensitive, and they've got RGB backlights. So the harder you press it, the color will change. And this is just default, like, hey, I'm working, this is a test kind of thing. And we can actually, here's a good demo. Okay, so recently I trying to make Substack proud here. Recently I made the temp pad into a streamable interface. Wow, what is going on there? If I could copy and paste, it would be just fantastic. Okay. Wow. This is going to work. I can feel it. Okay. Now. Read off the best of people. So now, if you go to Twitter, I'll do one of these, and you tweet, I hope this works, it's a lot of effort, Empire.js, and then the button index, pound, hex, right, so FF0000, I have to send it. Is it going to work? Probably exploded. Very weird. Let's just try that. Okay, so it came through, but
Twitter streaming is slow.
yeah. Or maybe it like sampled out that one tweet or something. All right. Well, if I just go into I should be able to just. Oh, that didn't work either. Perfect. Perfect. Couldn't imagine a better demo. All right. Okay, to prove that something is working. Hopefully. Oh, it exploded. here's a little demo to show that pressure works as expected. If I hit it really hard, it detects. Thank you. You hit it really hard, it detects and it lights up like you've actually pressed it. You press it really slow, it stays. Okay, you haven't gotten over the debounce threshold, so we're not going to turn this on. But if you did it, we'll say it's on. Which is kind of fun. And it makes it a lot easier to test, because then you can see, like, how did it bounce, and get better feedback there. So we can also do cool stuff. You can animate, just a simple demo. It's like 30 lines of code.
That's my code. I can see my tail.
What's that?
I forgot,
Michael's code.
I forgot that I wrote it and then I saw my tail and I'm like, nobody does that.
Okay, so that's just animating through the buttons. We can also animate on HSV, which is even less code. That's pretty well. It's not going to detect it. There we go. Yeah, so it's full RGB, which is awesome. Okay. Collecting my thoughts. What else will work? Oh, right. Okay, sorry. Kind of threw me with the Twitter thing. So, since we're in Node, we can use like C libraries and all kinds of stuff. So we can also use Node MIDI, which is kind of awesome. Unfortunately, we don't have audio, so I don't know if you can hear that.
Put the mic up to you. Your laptop.
No? Can you hear it?
Yeah.
All right. All right, so that's fun, right? So now we can actually properly replace the MIDI drum pad, which is exactly what I was going for. Yes. And so I gave a couple of these away as kind of like a beta test. And I gave Michael one, and he gave it to Max Ogden. And Max wrote this pretty cool drum pad thing with HTML5. I'll show you that. But I had to make some adjustments. Oh, this is a bad time to be installing. So anyway, it was a very simple drum pad, and we actually used it at summer camp where we were boogieing up Boogie Barn with temp pads and some weird, crazy, experimental audio stuff. It was fun. It was a good time. Please install. This is like, yeah. Look at that. In fact, I think there's one here. Whoa. Alright, so if you don't know Max, he's right there, his big beard. So we've rigged this thing up. There was a GIF that was circulating the internet that had Max in it doing an outland. And so I decided, hey, why don't I take Max's demo and actually add the two together? Right, so we got We got Felix, meowing. Can you guys hear that? Sort of? Okay. We got Max doing some drumming action. Yeah. And then he also bobs his head when he hit the kick drum. Oh yeah. Oh yeah.
I approve.
Yes.